Okay, back for the second Stoic video. I'm doing some more examples here. Example number 2 from your notes. If you had an abundant supply of oxygen and needed to produce 8.9 moles of Na2O, how many grams of sodium would you need? Now, abundant supply of oxygen, that's another way of saying excess oxygen. Basically means you can ignore oxygen. You don't have to worry about it. We got more than we need. So I read the question and I have my starting number, 8.9 moles of Na2O. So that's where I'm going to start. So starting number with the unit, with the chemical times blank line, unit and the chemical automatically go on the bottom. You should hopefully by this point be able to do this fairly automatically. Now it's where we go from here that can be kind of tricky. Since we have moles, we can use our balanced equation, which I should probably write up here again. So that's my balanced equation. Again, that's a 2, not a z. 4Na plus 1O2 makes 2Na2O. And since I have moles, I can jump right in and use my balanced equation to go from moles of one chemical to moles of a different chemical. In this case, I'm going to sodium. Again, if you're still not quite seeing how that works, the roadmap might help you. So we're starting at moles. We always start over on the left of our roadmap, so we're going to start at moles. And the question is asking how many grams. So we're going to go over to grams over here. Now you notice this is a 2-step question. So 1, 2 steps. My starting chemical, the chemical with that I'm starting with is Na2O. And I'm trying to get 2 grams of sodium. So grams of sodium, Na. So I got my roadmap set up. I'm at moles of Na2O right here. Moles Na2O. My first step, because I can't go directly from moles of Na2O directly to grams of Na. If I look at my map, I got to go somewhere first. And that first stop is going to be at moles of Na. So again, starting at moles of Na2O, my first stop is moles of Na. So that's what goes on top. Now I'm not where I want to be yet. I still got to go to grams. So I just tag on another conversion factor. Just like the starting unit always goes on the bottom, the top unit from this conversion factor has to go on the bottom. And we do this kind of alternating top and bottom thing so that they cancel. So if I look at my map, I'm at moles of Na here. My next step is to grams of Na. So that's what the unit on top will be. And I can, again, double check to see if it's set up right at this point. Moles of Na2O and moles of Na2O, those are going to cancel. Moles of Na, those are going to cancel. The unit I'm going to be left with is grams of Na, which is what my question is asking for. How many grams of sodium? So now it's just a matter of remembering what numbers go where. And moles over moles, we look at our balanced equation. So the mole ratio we get from our recipe. Moles over moles, we look at a recipe. Whatever number in front of Na up here goes in front of Na here. Na2O, there's a 2 in front, so I put a 2 there. Now for this conversion factor, I have grams and moles. So just like before, when mole is with grams, mole is always 1. And grams, hopefully remember where to get that. The grams number comes from the periodic table. So I look up Na. I can get Na. There we go. 22.989770. See if I can squeeze that in here. 22.989770. A little sloppy there, but so again, time to get out the calculator because it's all set up. And again, the way I type that in is starting number, 8.9, times the top number, times 4, divide by 2, sorry, because it's 2's on the bottom, I'm going to divide by it, divide by 2, and times, because it's on top, the 22 number, 22.989770, and divide by 1. I don't really have to do that, but technically we are doing that because it's on the bottom, but it's a 1, so it doesn't change anything. So my calculator says 409.217906. If I look, I want 2 sig figs, so again I get 409.2 something. 2 sig figs, so I cut it off right there. What's that 9 gonna do to the 0? Change it to a 1, so 41. But I'm not going to round 409 down to 41, so I got to put that 0 there, so 410. Moles of Na2O, moles of Na2 cancel. Moles Na cancel. The only unit left is grams of Na, which is good because that's what we're looking for, grams of sodium, grams of Na. So hopefully that makes sense. I don't know where that little line came from there, but I wish this thing had an eraser. Oh well. So 410 grams of Na should have been your final answer there. Let's do another one. Whoa, I hate when I do that. So, next question. Again, same equation. So I'll put that up at the top here. 4Na plus 102 makes 2Na2O. Again, the map, if it helps you, great. If you can kind of see what to do and see the pattern of this without the map, great too. In this question, it says if you had 52.8 grams of Na, so that's my starting number, 52.8 grams of Na, and an abundant supply of oxygen, again meaning extra oxygen, we don't care how much, or it doesn't matter, oxygen doesn't matter because we've got plenty of it. How many grams of Na2O should be produced? So if we think of our roadmap here, well actually let's get this started because there's some things we can automatically do here. Grams of Na can automatically go on the bottom. And I'm starting at grams, so I'm starting here on my map, and I'm looking for grams of the other chemical, so grams on the other side over here. So this is going to be a 3-step question. First step, second step, third step, which means we're going to have 3 conversion factors. Our starting chemical in this case, grams of Na, so I'm starting with Na, and I'm trying to end up with grams of Na2O. So I got my map set up. First step is from grams of Na to moles of Na. So that's what my first conversion factor looks like. Grams of Na is on the bottom because its starting unit automatically goes on the bottom. The other one, top unit, is moles of Na, and I can see that with my first step here. So I'm not where I need to be yet. Another conversion factor. Top unit always goes on the bottom of the next one. So now I'm at moles of Na, and my next step is to moles of Na2O. So I'm at moles of Na2O. I'm still not where I need to be though. Another conversion factor. Top unit goes in the bottom. And the last step is from moles of Na2O to grams of Na2O. There's a couple numbers I can put in right away because mole and grams together, mole is always 1. Mole and grams together, mole is always 1. Moles and moles, I look at my balance equation. Na2O, well, that's a 2. Na, well, that's a 4. Grams of Na, I know that number from the last example. And grams of Na2O. This is a bit more work. I gotta take the red number for Na times 2, add that to the red number for oxygen. We're running a little low on time, so I'm going to pause it and do that real quick. So I did that math down here. You wouldn't necessarily need to show this work. If you've got a graphing calculator, you can kind of see all this. You don't need to write it down anywhere. If you just want to do it in your calculator or whatever. I'm showing it here just to show you what I did. So I got Na2O, so I took 2 times the red number from the periodic table for Na. I got 1O, so I did 1 times the red number for oxygen. Did that math, added it all together, and I get 61.97894. So that's what goes in here, 61.97894. And then again, it's just a matter of doing the math. If I can find my calculator, there it is. So 52.8 times the top number, that's a 1, so I can skip it, divided by, since it's on the bottom, 22.989770 times 2, because it's on top, divide by 4, because it's on the bottom, and times 61.97894 equals that. So, and I want 3 sig figs, so 71.1727. That's going to equal 71.2. Oh, that looks like a Z. That's a 2. 71.2, because I cut it off here, and the 7 makes the 1 round up. Yep. And grams of Na, grams Na, moles Na, moles Na, moles Na2O, moles Na2O. We're left with grams Na2O. That is my final answer, 71.2 grams of Na2O. And that makes sense because the question is asking for how many grams of Na2O. So, third example. That brings us, I think, to the end of the second video here. What I will probably do, there's a couple more examples. I'm going to do them really quickly, hopefully get them done in, just a short video, maybe a 5-minute video. I'll kind of go through them real quick, show the answers, show the work, move on to the next. But that pretty much covers the main aspects of stoichiometry. There's a couple other little differences for the next 2 examples. You just use some of those other units like liters or atoms or molecules. But the process is the same as this. So again, we'll call it quits for this video. I'll do one more video during the rest of the examples, but I'll do them fairly quickly. Like usual, if you have questions, stop in, send an email, something like that.